Welcome to the Dobot Lab Final Project Summary. In this overview, we will delve into the culmination of the learning journey where we applied skills acquired in multiple labs to tackle a challenging task, which was completing a wooden children's wood puzzle. Throughout Labs 1 through 3, we had gained technical understanding of the Dobot's code and functionality. This includes the robot's main control, camera-guided system, code, and calibration techniques. Now, let's explore the Dobot's abilities. In Lab 1, we explored the basics of robot-to-robot interaction. Initially, we started with the essentials by learning how to use the Dobot Vision Studio software, requiring us to switch between suction cup and the gripper devices for diverse tasks. Also, we mastered the control over the peripherals like the conveyor belts, utilizing I/O communication with start and stop commands to detect when objects were ready to pick up. This allowed us to synchronize the Dobot's actions and coordinate tasks effectively in a collaborative environment. Lab 2 begins with capturing and opening images using the Dobot Vision Studio, allowing us to learn camera manipulation for optimal image quality. Further, we are able to use image processing techniques such as feature matching, point-to-point measurement, and color extraction. For instance, we were able to create templates for identifying specific objects as well as be able to measure the distance and angle between objects. As a result, we were able to program the Dobot to pick up and sort colored blocks based on our own predefined criteria, allowing us to identify and move blocks of colors that we selected. Lab 3 taught us concepts of robot control and communication. This lab was split into two parts: robot-to-robot interaction with vision-guided robotics. In the interaction, two teams collaborated to establish communications between two Dobots. One team is sending the signal and the other is receiving the signal. This involved building circuitry, connecting them to the Dobots, and programming for sending and receiving. In the vision-guided section, we were tasked with detecting and then moving rectangular objects using image processing. This involved calibration of the Dobot and creating a flowchart programming and coding to calculate the correct angles for object manipulation. Overall, this lab allowed us to understand advanced vision-guided movement of the Dobot, enhancing our understanding of the final project. The final project utilizes all of the skills we gained throughout Labs 1 through 3 to accomplish the goal of completing a wooden children's word puzzle. This goal was split into two general tasks, and we worked together with another team to accomplish these tasks. The first task is to identify the correct puzzle pieces to complete the predetermined puzzle and sending them to the other team. And the second task is receiving these puzzle pieces from the other team and correctly placing these puzzle pieces to complete the puzzle. The first task of sending the correct puzzle pieces mainly focused on the identification of the correct color. To do this, we employed the color extraction flow that was explored in Lab 2. Since we were given several letters of different colors, employing the color extraction flow allowed us to focus solely on the puzzle pieces of the color that we needed. Once the Dobot recognized and focused the pieces of the correct color, we used fast match flow to identify the correct letters to complete the puzzle. We then used move points and suction cup functionality to pick up these letters and place them on the other team's workspace. The second task was to correctly position the letters in the puzzle once they were received from the other team. We used the fast match functionality to identify the first letter of the puzzle. We then used fast match to identify the correct space in the puzzle and place the letter. Using the shell module code utilized in Lab 3, we calculated the angle of the piece needed to be rotated to fit correctly in the puzzle space. Using move points and suction cup functionality, we picked up each letter, rotated it to the desired angle, and placed it in the corresponding space. When executing our flow during the final test runs, our team ran into a few problems during both of the tasks. For both tasks, we were unable to get the I/O function to work correctly. Our Dobot failed to send and receive the signal from the other Dobot and triggered the next stage of the flow. For the first task of sending the letters, the biggest issue we ran into was our Dobot mistaking the letter C for the letter A. Our flow ordered the Dobot to first identify the letter A and move it to the other team's workspace. But since it mistook the letter C for the letter A, we were unsuccessful in moving this piece. After this initial issue, our flow worked as planned. Our Dobot successfully identified, picked up, and moved the letter C and R to the other team's workspace. The second task of receiving and placing the letters correctly in the puzzle faced difficulties as well. We were able to correctly identify, pick up, rotate, and place the letter C. However, our Dobot failed to identify the letter A. It mistook the puzzle space for the letter. This is most likely due to the presence of the tape on the letter A piece, which was added by the other team in aid of picking up the piece with the suction cup. Our Dobot successfully identified the letter T, and it began executing the rotation code. However, the Dobot failed to identify the T in the incorrect location. The reason of this issue is less clear. It could potentially be due to the T puzzle space being out of frame or a glare of the overhead light, causing misidentification with the fast match functionality. Overall, this project allowed us to explore the Dobot functionalities and applications. We learned several specific skills throughout Labs 1 through 3, including calibration, feature identification, color matching, and shell modules. We were then able to apply these skills and use them in different ways through the development of our final project. While our final project was only semi-successful, we developed skills in applying Dobot commands and functionalities to complete the tasks to the best of our ability.